Points E, F, G, H lie on the sides AB, BC, CD and DA respectively of a square ABCD. If EFGH is also a square whose area 62.5%, that's a special number, of that of ABCD and CG is longer than EB, then the ratio of the length of EB to that of CG is, okay, let's first put that outer square ABCD. Let this be the outer square ABCD. Let's label it A, B, C and D. Okay, now we'll have to put those points inside, keeping in mind of the fact that CG should be longer than EB. So G should come more towards D, right? So let's put the next square as well inside. It would be something like this. Now let's label this one as well. We have got E, F, G and H. E will be on AB. So this is going to be on AB. E, F, G and H. And the point that they have given, CG is longer than EB. That's visually satisfying in this figure. You need not exactly follow that, but keep in mind that CG is longer than EB. Great. So what I'm going to do is I'm going to label these parts of the sides. For instance, CG is the longer side, so let me just label it as L. And the shorter part of the side, I'm going to label it as S. As we have a square inside a square, there is some amount of symmetry that you can assume. So for every side of the big square, I'm going to have L and S in this case. Okay, so this part BF is going to be L and CF is going to be S. EB, the shorter one, is going to be S. EA, the longer one, is going to be L. HA, the shorter one, is going to be S. This is going to be L. Now this can actually be proved as to why there are going to be 4 L's and 4 S's in this figure, but I'm not going to get into that right now because I lose the momentum for this question. But I am going to come and explain about that when we go to the end of the question. So right now, let's take the symmetry aspect and go forward. We will look at why they would be so after we have solved this question. So let's look at this. If they were LS, LS and so on. Now the question is asking for length of EB, which in our example, as per the labeling, is S, and CG, as per the labeling, is L. So S is to L is what they're asking for. Now let's try and form some relationship inside this triangle GCF. This is going to be 90 degrees because it's a square. So this is a right angled triangle that we have. So we can apply Pythagoras theorem here. So L square plus S square is going to be GF whole square. And what is GF whole square? That is area of the smaller square. And it is given that area of the smaller square is 62.5% of the bigger square. So instead of writing GF whole square, I could write it is 62.5% of the side of the big square whole square. That's going to be S plus L whole square. So L square plus S square is equal to 62.5% of S plus L whole square. Now what is 62.5? That's a special number. 62.5% is 5 into 12.5%, and 12.5% in terms of fraction is 1/8. So it's 5 into 1/8. So this is basically 5/8. So 62.5% is 5/8. Now these are not calculations you should be doing in the exam. You should be immediately be able to identify that 62.5% of something is 5/8 of something. So instead of 62.5, I can put 5/8. So we have got L square plus S square is 5/8 of L square plus S square plus 2SL. So if I do some calculation here, so I'll have 5/8 of L square, 5/8 of S square. Here I have L square and S square. I could just make it 3/8 of L square plus 3/8 of S square is equal to 5/8 of 2SL. Now we could have actually started this whole calculation by taking one of them as 1 and the other one we could have adjusted accordingly, but I wanted you to go through this path and reach this stage, because some of you might reach this stage while solving the question, and that time you should understand how to resolve it, because we have come to a stage where we have a quadratic equation where you have got two variables, only one equation. Now in these kind of situations, if you are asked to find a ratio, there is something you can do which can make your job much easier. So what you can do is, instead of taking S and L, you can assume one of them to be 1 and accordingly adjust the other one. For instance, let's say we have got speed of A is to speed of B as 3:4. Now instead of taking it as 3:4, I could take speed of A as 1 and speed of B as 4/3. It's still conveying the same meaning, right? So as far as ratios are concerned, you can take one as 1, adjust the other one accordingly. So what I'm going to do is I'm going to assume S to be 1 and L I'm going to adjust accordingly. So now I'm going to find out what will be L value if S is going to be equal to 1. We are doing that because we are only looking at getting the ratios. That's critical. You cannot just assume 1 for S. Okay, because it is ratios, I'm assuming 1 for S. So if I put 1 for S, it is going to simplify my equation. So now what do we have? We have got 3/8 L square plus 3/8 into 1 square is equal to 5/8 into 2L. That's going to be 10/8 L. Now I can multiply the entire equation by 8, get rid of the 8 from the denominator. So that will give us 3L square minus 10L plus 3 is equal to 0. Now let's try and simplify this. So we have got 3L squared minus 10L. So 3 into 3 is 9 and I should get minus 10 here. So probably I can go for minus 9 and minus 1, right? And if I look at the ratio here, it is 1:-3. This 3 and minus 9. It's 1:-3. I also have 1:-3 here. So one of my factors is going to be L minus 3. I'm using that 1:-3 ratio. And the other one, I can divide 3L squared by L, that leaves me with 3L, and I can divide plus 3 by minus 3, that will leave me with minus 1. So this can be written as L minus 3 into 3L minus 1. Now what I did here gives you a bit of an edge in the exam. You can also split it as 3L squared minus 9L minus L plus 3 is equal to 0 and go through the regular way. Okay, now here if A into B is equal to 0, either A is equal to 0 or B is equal to 0. So I have to equate each one of them to 0 and get the value for L. So if I'm going to equate this to 0, then L minus 3 is equal to 0. I'll get L is equal to 3. If I take this, then 3L minus 1 is equal to 0. I'll get L is equal to 1/3. So we've got two values for L. L is equal to 3, L is equal to 1/3. If I put L is equal to 3 here, the ratio will be 1:3. I cannot put L is equal to 1/3 here because that would give me 3:1 as the ratio. The shorter side cannot be longer than the longer side. It cannot have a bigger value than the longer side. It's clearly given CG is longer than EB. So I have to go for L is equal to 3 in this case and not L is equal to 1/3. And the moment I go for L is equal to 3, we'll get the ratio as 1:3 for this question. Answer is 1:3. Now coming to the part where we assumed that each of the longer parts of the sites is equal to L and each of the shorter parts is equal to S. That can be very easily proved. Now if you look at this part, let's say this is angle A and this is angle B. This is going to be 90 degrees. Similarly here, this part, if you look at this entire area, the whole thing is going to be 180 degrees. And here I have 90 degrees. So A plus this value should be equal to another 90, right? And we also know A plus B is equal to 90. So this is going to be B. In that case, this is going to be A. Now, if you look at HDG and GFC, these two are congruent triangles. How do we know that? Because we have got angle, side, angle, angle, side, angle. So B is equal to B. This side is equal to this side because they are sides of a square, and we have got A and A. So these two are congruent triangles. So the side opposite angle A and the side opposite angle A, they both should be equal. So they both should be L and L. Similarly, these two should be S and S. If you can prove that for this part to this part, you can also prove that for LS and LS here. If you can prove that, you can also extend it. And that's how you can prove that you're going to have 4 L's and 4 S's. But that kind of a symmetry in exam can be assumed because we have a square inside a square.